We will discuss now, working principle of diode. An N-type semiconductor block will have a significant number of free electrons. And very little number of holes. Holes present in N-type semiconductor due to generation of electron-hole pairs mainly caused by thermal excitation. A P-type semiconductor block will have a significant number of holes. And very little number of free electrons. Free electrons present in P-type semiconductor due to generation of electron-hole pairs mainly caused by thermal excitation. Let us create a simple p-n junction diode. Let us join an N-type and a P-type material together. The majority carriers in N-type material are free electrons. The majority carriers in P-type material are holes. Let us see what happens at the junction of these two materials. Adjacent to this junction edge, free electrons in the N-type material will recombine with holes in the P-type material. As a result, there will be lack of free electrons and holes across this region. This region is called depletion region. We know that an N-type material is electrically neutral because the number of free electrons and positive donor ions are same in an isolated N-type material. Similarly, a P-type material is electrically neutral because the number of holes and negative acceptor ions are same in an isolated P-type material. After absorption of free electrons in N-type side of in depletion region, uncovered positive donor ions will remain there. After absorption of holes in P-type side of in depletion region, uncovered negative acceptor ions will remain there. This region of uncovered positive and negative ions is called the depletion region due to the depletion of free carriers in the region. Due to the presence of these positive and negative ions, a static electric field called as barrier potential is created across the junction. It is called as barrier potential because it acts as a barrier and opposes the further migration of holes and electrons across the junction. Now, we connect link to the ends of each material. We made the basic p-n junction diode. Now, we connect positive terminal of the voltage source to the link connected to P-type side. And, we connect negative terminal of the voltage source to the link connected to N-type side. In this condition, diode is said to be in forward biased condition. We already told that there is a barrier potential across the junction. This barrier potential acts in the opposite of the forward applied voltage. So can only limit the current by connecting external resistances series with the diode. Now, we connect the negative terminal of the voltage source to the link connected to P-type side. And, we connect positive terminal of the voltage source to the link connected to N-type side. In this condition, diode is said to be in reverse biased condition. Due to attraction of positive potential, the free electrons in N-type region go away from the junction. Due to attraction of negative potential, the holes in P-type region go away from the junction. This makes the depletion layer of the junction wider with increasing reverse biased voltage. The current does not flow through the diode. This is because free electrons in N-type region and holes in P-type region cannot cross this wide depletion region due to electrostatic force of the applied reverse voltage. As we told earlier, there are always some thermally generated holes in N-type semiconductor and free electrons in P-type semiconductor. We call these charge carriers as minority charge carriers. These minority charge carriers also present in depletion region. due to electrostatic force of applied reverse biased voltage. These minority carriers will smoothly flow through the diode. Because the polarity of reverse biased barrier potential does not oppose the flow of holes from N-type to P-type region, and free electrons from P-type to the N-type region. As the number of minority carriers is very few, a tiny current flows from N-type end to P-type end in the diode. This current is called reverse saturation current.